Okay, so hello everyone, welcome. Can you hear me? Okay. Okay, so just we are waiting 1 or 2 minutes for joining all of the other participant and then we'll start. Okay, so now we'll start. So I simply share my screen. Okay, so now can you see my screen? Is it visible? Okay. Okay, so let's go to this class. So basically today I will try to discuss about for the change detection, how we can easily calculate the change detection area, as well as how we can easily show the land use land cover class change. Suppose here you can see here I already created 2 decade map. So one is that a land use land cover classification map 2021, and another is that land use land cover classification map 1991. Okay, so two types of land use land cover classification map I created already. So now I will show you how we can easily calculate it, the change detection area, how much area will be increasing or decreasing for the 2 decade. Okay, this type of calculation, as well as we also try to show you that how we can easily show the specific class wise change detection. Suppose you can see this type of map, how we can easily calculate the change of a change area, all of those classes, where it will be changed or not changed. Suppose yeah, water body turn into build up area, or barren land turn into vegetation or build up area. So this type of analysis how we can easily do using the Google Earth Engine platform, and also calculated the transition area. Suppose in 1991 we can get the lot of water body or lot of open space, but 2021 we can find out the lot of build up area. Okay, so how much build up area will be increasing in 2021? Okay, so this type of calculation how we can easily do this, today I also try to discuss. Okay, so let's go. So basically I already provide you this type of code, how you can easily work with that, and also make the how you can easily make the land use land cover classification. We already covered this part. So basically today I will try to discuss about that change detection part, how we can easily make the change detection 2 decade land use land cover classification map. Okay, so I already created. Okay, this is the map for 1991. We can get the very small area of the urban or build up area, but 2021 we can see the lot of build up area will be increasing. Okay, so let's go. We also try to mainly in this time we classified only for the water, build up, vegetation, and others. Okay, total 4 classes. Okay, 2 time period 1991 and 2021. Okay, so let's go. So this is our code. I already send you the code about this classification, and I again explain about the classification. Then we will start. Okay. So first of all, we can simply import our shape file. Okay, and also imported in this time SRTM not need. So I minimize it. Okay, elevation data we not consider in here. Okay. So then water, build up area, vegetation, others we can take the training point as well as also take the training point for the 2021. Okay. Okay. Okay, so in this time first of all you can see here I already added this type of image. So 1991, this is the image for 1991 and this is the image for 2021. Okay, 2 decade image I added in here and take the training point both of images. Okay, suppose I take the training point for 1991 water, build up, vegetation, and others, as well as also open the image for 2021. This is the image for 2021, and also take the training point for the 2021 also. Okay, so I take the training point for the both of satellite images 2021 and 1991. Okay, we can see this is the image for 2021 and this is the image for 1991. Okay, after that we can simply use here the classification. All of the thing will be same process. This code for the removing the cloud and haze from the satellite image. Okay, and after that we can simply add all of those band we can add in here. Okay, and then annual image collection we can create it for the 2001, 2020, 11, 2001 and 91. But I want to work only for the 2021 and 1991. Okay, these 2 decade I choose and make this classification. Okay, so first of all I can simply all of those training sample for water 1991 to all of this I merge for 1991 and all of those training point merge for 2021. Okay, then use here the some band about that. Okay, after that extract that make the training data set. Okay, and this training data set we can simply separate 70% data for train our model and 30% data for testing our model. We are using here the random forest and use the decision tree is the 150 and classify. Okay, and also check the accuracy. So all of this part I already discussed. So in this time we can create the 2 types of map. You can see. So first of all is that classified map for 1991. So this is the map for 1991 and also create the another classified map for 2021. Okay, so now we try to discuss about that change detection, how we can easily make the change detection using the 2 time period land use land cover classification map. So first of all I try to show you that how we can easily calculate the transition area. So how much water body convert into the build up area, how much vegetation convert into the build up area, how much vegetation convert into the barren land. Okay, so this type of statistical part how we can easily calculate it using the Google Earth Engine platform. This part I try to discuss. Okay, so first when you want to make the land use land cover classification change detection, first step is that we need to make the reclassify. First step is that reclassify. Okay, so reclassify is that here we can get the 2 types of map. One is the 2021 and one is the 1991. Okay, so 2021 has the total 4 class and also 1991 has also 4 class. So first of all I need to reclassify. Okay, and here you can see 1991 it's a before and 2021 it's a after. Okay, so it is the before and it's the after. Okay, so because it's the past time. Okay, and then it's after 2021. Okay, so first of all I need to reclassify the class value. Okay, so here you can see when I want to take the training class, first of all it is the 0. Okay, and then we can put the build up, it's the 1. Okay, and then also you can see the vegetation 2, then 3, then 4. Also build in here about put here the water is the 0, then build up is the 1, then vegetation will be 3 and 2, and water is the 3. Okay, so 0 1 2 3, total 4 class. In this time we reclassify this class value. Suppose 0 will be 1, 1 will be 2, 2 will be 3, 4 will 3 will be 4. Okay, so we just reclassify this class number. Okay, so let's go first of all reclassify. So class number. So I take a variable name. Suppose I put the variable name is that before class. You can use any variable name. I put the variable name is the before class. And what is the before class? Before class is that 1991. Okay, just I simply copy. Okay, I reclassify it because this map has including all of those class from 0 to 3. Okay, but in this time I convert it 1 to 4. Okay, so let's go. So I simply use a function for the reclassify, use here the remap function. Remap. So remap, first of all I put here this class 0, then 1, then 2, and then 3. Okay, this 0 1 2 3 I convert 1 2 3 4. Okay, just I simply put here this another square bracket, put here 0 will be 1, then 1 will be 2, 2 will be 3, and 3 will be 4. Okay, so just I simply reclassify. Okay, so 0 1 to 3 convert into 1 2 3 4. So in this time 1 is that water. Okay, 1 is that water because I reclassify. Then 2 is the build up area, 3 is the vegetation, and 4 is the others because I simply reclassify it. Okay, and then also make the other reclassify for the 2021. Okay, so I take a variable. Suppose I put the variable name is that after class and call this, simply copy and paste here and use here the remap function. Okay, and put here this 0, then 1, then 2, then 3. Okay, now it convert into 1 2 3 and 4. Okay, so I reclassify both of things. Okay, in this time I want to calculate the all changed area, not any specific class, all class changes area. Okay, so let's go. Just I can simply subtract from before class to after class to before class. So just take a variable. Suppose I put the variable is that changed. Okay, in the changed I simply call this after class, subtract with before class. Okay, and after that I put here the n equal to 0. Okay, so now I display the result. So mainly it's showing the overall changes, not any specific class. So just I simply put here the map.add layer and call the changed, click copy and paste. Okay, and I show the result. Mean it will be 0 and max 1. Okay, and also add here the plated and make the list of the plated. Plated white and suppose red. Okay, so white means that there is the no change, red means that changed area. So now click to the run. In this time it display the overall changes, not any specific classes. Okay, we did not the strm, we don't need. I click the run again. Loaded. Okay, where is the code? Yeah. So now I think this layer is that. Yeah, this layer. Yeah. In this time, it's showing the overall changes area. Okay, not any specific class. Red color means that it changed, and white color means that there is the no change. Okay, so and what class is changed, we show the another method for display this class, but in this time this layer showing the overall changes. Okay, suppose we can get the red and white. This white means that there is the no change. Suppose this white color is in this place, it's showing the vegetation, and the 2021 we can also get the vegetation, so there is the no change. Okay, so that's why it's showing the white color. And red color, suppose it can be vegetation now, year of 1991, now it's the build up area or other classes. Okay, it also changed, but which class is changed specifically we don't know. Okay, so it's showing the overall changes, but if you want we can also show the class wise change. Suppose water body turn into vegetation, which area, then water body turn into the build up area, which area, we can also display the result. Okay, so after calculate the transition area, we discuss about that class wise land use land cover classification. Okay, so let's go. So in this time it's showing the result for the changed and unchanged area. Okay, and we also reclassify it. So now our next step is that we need to calculate the transition area. Okay, for calculating the transition area we need to apply a formula. Okay, so calculation transition area formula, we need to apply formula. This formula is that before class multiply with, okay, I write the formula directly. I take a variable and put the variable name, suppose March, and I simply call this before class multiply with 100, then add with after class. Okay, so this is the formula, and I put this rename it as a transitions. Okay, so this is the formula before class multiply with 100 and add with after class. Okay, so we are use this formula because you can say when I print that, then we can get the result about that merge, and click to the run. I add here the same notation, then it also better. Yes, you can see in this time we can get this integer 101 to 404. Okay, so transition integer value belongs with 101 to 404. Okay, so it means that in this time we can get total all of this class. Such class is that I also write that. Suppose we can get the result first of all, suppose 101. Okay, also get the result for 102. Okay, also get the result for 103, also get the result for 104. Okay, also get the result for 201. Okay, also get the result for 202, also get the result for 203, also get the result for 204. Okay, and like that same, also result for 301, also get the result for 302, also get the result for 303, same 304. And lastly we can also get the class for 401 and also get that 402, get the result for 403, and finally 404. Okay, so it means that we can all of those class transition. Okay, so now what is the meaning about the 101, 102, 103? So first of all, 101 means that, suppose, what is the one is that water. So water to water. Okay, what is the meaning for 102? Water to build up. Okay, what is the meaning for 103? Water to hesitation. Okay, what is the meaning for 104? 104 means that water to others. Okay, same as 201. What is the meaning for to build up? Build up to water. 202 means that build up to build up. Okay, 203 same, 20 build up to vegetation. 204, what is the 204? Build up to others. Okay, so it's the transition means that, suppose water, how much we can get the how much area will be increased for the water, how much area convert into the build up area. Okay, how much water convert into the vegetation, how much water convert into the others, how much build up area convert into water, how much build up area convert into the build up area in 2021, how much build up area convert into the vegetation, how much build up area convert into the others. Okay, so I think you are also idea about the 301 or 302, what is that meaning for the transition. Okay, so anyone in question, if can ask me, or any doubt any time you can ask me, there is no problem, just unmute and ask me. Okay, then for 304, like the 401 or 402, same. Okay, so in this time we calculate all of those area. Okay, how much area will be convert for this 2 decade, we can calculate it, that how much build up area convert into the water, how much build up area convert into the vegetation. Okay, so this type of calculation we can calculate it. Okay, so this is a transition. In this time I use this formula. Why I use this formula? Because when I use this formula, before class multiply with 100 and add with after class, then I can get this result look like that, 101 to 404. Okay, so 101 to 404, when I multiply 100 and add with after class, then I can get this result, and it's my transition 101, 102, 103. Okay, and when I calculate this area, then we can easily get the result about the transition area. So for getting the 101, 102, 103, for that I use this formula, and 101, 102, for that when I reclassify it, because I need the result 102, 202, 203, like that. So that's why I reclassify this class number. First of all, it's showing the 0, 1, 2, 3, but when I convert it, reclassify and turn, 0 will be 1, 1 will be 2, 2 will be 3, 3 will be 4. Okay, so now we can easily add calculate a transition area. Okay, so let's go. Okay, so this is a transition area. In this time we can calculate it, and we already merge and also get the transition 101, 102, 103, all of those things we can get in here. Okay, so now first of all we need to calculate it the pixel. Okay, pixel area, how much pixel is available for this. We need to use the frequency histogram and calculate the pixel. Okay, so for that I simply take a variable. Suppose put the variable name is that transition matrix. Okay, transition matrix, and then call this merged, because it stored all of those from 101 to 404. All of those is stored in here. Okay, so then paste here, and then I use a function reduce region, and in this function I put a frequency histogram. I put here this. First of all, reducer. In this term, I put here the reducer as a frequency histogram. Mainly, it calculated the per class how many pixel is available. Per class, how many pixel number. Okay, not calc area. It showing the pixel number. So I put here that e dot reducer dot frequency histogram. Frequency histogram, and our geometry is our boundary area. Our boundary is that ry. I check what is the name of this shape file. Sorry, AOI. Put here the AOI. AOI scale is the resolution. So Landsat image we are using at the 30-meter resolution. And then I simply remove all of the not need. Okay, now I print this. Print. I'll put here the frequency. So now I simply print that transition matrix and click to the run. So we can get that per pixel how many class is available. So we can check the result. Yeah, frequency histogram. Yeah. So here you can see total 14 properties. So you can see 101, 104, 201, 202, 203, 204, 301. Okay. Okay. So in this time we can see we did not find out the 102 and 103 because it very less area conversion. So that's why it not including in here. Very less area. So that's why it not including in here. Or very much pixel number. Okay. So in this time we can get the 101 how much pixel, 104 how much pixel, 201 how much pixel, 203 202 how much pixel. Okay. 303 how much pixel, 304 all of those things we can get in here. And which class is not available, it means that it's very less area or less conversion, that's why it's not showing in here. Okay, so in this time we can get all of those pixel number, how much pixel is available for that. So now from this pixel number we can simply calculate the area. 101 what is the area, 104 what is the area, 201 what is the area, 202 what is the area, and what is the 202, 101, 104. I hope you already understand about this topic. 101, 104, 202. Okay, 10 means that water to water, 102 means the water to build up area, 103 is the water to vegetation, 104 is the water to others. Okay, 201 means the build up to water. Okay, this same as that. Okay, we can get this pixel number. So now from that we calculated the area, how much area is available for how much. Okay, so just we can calculate the area. Okay, so after frequency histogram we calculated the area. For calculating the area, okay, so I take a variable, suppose area image. In area image we can use the function e dot image dot pixel area. Basically this function calculated the area in a square meter. Okay, So I want to calculate the area in square kilometer. So what I simply divide with 1 million, or 1 into 10 to the power 6, or 1 is 6. Okay, so now it convert the square kilometer, and I want to calculate the area, all of this area. Okay, so I use at the I can simply use a function add bands and call this variable name merged. Simply copy and paste here. Paste. Okay, merged. So now I calculated the area. So take a variable area and call this area image and paste, and then use the function reduce region. Reduce region. So mainly reduce the function when you can calculate anything, any number or any maximum, minimum, or total pixel area. Then we are using at the reduce region. Lot of time we are using at the reduce region function. And now I simply make a dictionary using all of this argument. So make a curly bracket start and also curly bracket int. So then first of all reducer. In this time we calculated the total area, total transition area. Okay, so use at the ee dot reducer dot sum. Okay, not only for the one class, here the total 14 properties we can get in here. So that's why we need to create a group. Okay, so use at the group, and in this time put here the element group field and group name. So just I simply make a dictionary in here, curly bracket start and also curly bracket int. First of all, group field not randomly you can put here the one. Okay, field is only for the one. And group name we need to use here the transition. Okay, which I already created in here. You can see transition. Transition. So simply copy, paste here. Okay, then geometry is our boundary shape file variable name. It's the ry, sorry, aoi. Scale is the resolution. It's the 30-meter resolution. Okay, then it's not needed. I simply remove that. Okay, so now I simply just show the result. So just simply print put here transitions area. Okay, so now simply print that area. Click to the run. In this time it display the result and also calculate the area. So click on here. In this time we can get the list look like that. It called the nested list. Means that you can see when I click on here, it open a list, and when I also click on here, then also open a new list. So it's called the nested list. Okay, so this nested list we can easily convert as a flat list. Okay, so first of all you can see the transition 101, how much area, 0.6 square kilometer. Then you can see the another class is that 104, how much class, 0.0013 square kilometer. Also you can see the result about the another class, suppose 201, how much, 0.013 square kilometer. Click on here, we can get 202, how much area, 5.35 square kilometer. Okay, what is the 202? Build up area to build up area. Okay, click on here, 203, how much area, 0.05 square kilometer. Also you can see the another class. So in this time you can see this result is showing look like that, sum and transition as a nested list. Okay, so I want to show the result not nested list. show the result, very clear result want to show. Suppose I want to show the result like that. Suppose it's showing the result, suppose 101, and then also write the 0.66. Suppose also show the another result, suppose 20104. Directly it's showing look like that, then it also better. So that's why also need to help of function and then create this type of analysis. Suppose in this time you can see it showing the nested list. When I click on here, then it will be showing. But we are easily create the flattened list. This flattened list directly show the result. 101 how much area, 104 how much area. Okay. So for that we are need to help of function. We can easily create a function. This function just convert all of those things as a flat list. In this time it's showing the nested list. Nested list means that this is the one, click on here I can get a list, and also click on here, then I also get the another list. Okay, so this type of list called the nested list. We can easily convert the nested list as a flat list. Okay, then we can also represent it that data. Very good. So let's go for the nested list to convert list. For conversion we are using here, the another thing is that first of all we need to create a function. Okay, so take a variable, suppose class area list. Okay, and then e dot list. Okay, basically it is a list. You can see 0 1 2 3 4, it is a list, and this list come from this area. I paste here, and then I get it from groups because it's a group, so put here the groups, and then make a function. So take a variable, suppose function variable name, suppose class area list, and then put a function keyword, put the variable, suppose e item. In this item I want to add the two things. First of all I create a dictionary. In this dictionary I create the two item. One item is the class number, mainly 101 104, it's the class number, and another thing is that area 0.66 0.013. Okay, so first of all create a dictionary. Okay, so take a variable, suppose put the variable name is that area dict. Okay, and then e dot dictionary and put this element name item. Okay, so create a dictionary. In this dictionary I want to store the two things. One thing is that class number. Class number means that 101 104, this type of class number. So take a variable, suppose class number. Okay, and use here the e dot number, and then I want to get it from the dictionary. So simply copy the dictionary variable name and paste here, and use here the get. You can see mainly class number come from the transition. You can see 101, also you can see 104. It mainly is stored in the transition. So simply copy the transitions and paste here. Okay, after that mainly it's showing as a number. Okay, 104 is a number. So this number I want to convert in string. When I want to show the result 101 look like that, then it will be showing as a string. So that's why I need to use a function, format function. Okay, mainly format, it is a conversion function. It convert number, sorry, it convert number to string. Okay, so basically it's a number. Okay, but this number I want to convert into string. So that's why I simply put that. And take the another thing, suppose area. I put this variable name is the area, and area e dot number. Okay, and after that I also store it in a dictionary. So I call the dictionary variable name, and this area come from where I can get, you can see area, mainly area value is stored under the sum. You can see area value is stored always sum. Also you can see here, click on it, I can get the area sum. So just I simply copy the sum, and I can get it from the area. So I put here the sum, and this area I want to convert into suppose square kilometer. So put here the divide with 1 is 6. Okay, then it will work. So now my item is ready. After that just simply use the return function. Okay, so return what I can get. Mainly from this function I can get the two item, class number and area. So use at the ee dot list. My two item is that class number. One is class number. So just I simply copy class number. Another is one area. Okay. So I create this function. Okay. This function is created. So now this function I need to add with this list. Okay. So just I simply copy class area list and paste here and use a function map function. Map. Use the parenthesis and also close this parenthesis. So now it added. Okay. So now display the result. You can see just I simply take a variable. Suppose this variable name is that transition area. You can use any variable name. And then use at the ee dot dictionary and then call this variable function variable name class area list. And then paste here and use a function flatten function. Mainly this function convert the nested list into flatten function. So now simply print that. So uh, print this transition area. Okay, click the run. I also add here the citation. Suppose transition area. So now click to the run. In this time we can get the result 101, then how much area, 102, how much area. Okay. Also better about showing this result. Yes. Load it. Click on here. You can see 101 how much area, 104 how much area, 201 how much area. Okay. 203 how much area, 203. Okay. In this time we can get the look like that. Okay. Transition area. All of those classes transition area we can get in here. So 101 how much area in unit is a square kilometer. So that's why you can get the very low value in here. 104, 201, 202. Okay. 203. You can get the look like that. Okay, 301. Okay. So for this calculation, anyone any question you can ask me. Anyone any question or any doubt? For this transition area calculation. Yeah, please.
Hello.
Yeah, I can hear you.
In this classification, which ones we added added in the other class?
Added in the other class.
Hello.
Yeah, I can hear you.
Uh, which ones in the satellite image?
Okay, table. Yeah, it's also possible. Just we can simply copy all of those things. Okay, copy and open in Excel file. Just simply copy and open the Excel file. Then we can also make the table. And it also possible to add the table also in here. Just simply copy all of the things and open in Excel file. We can get the result two column. 101 number all of this column, another column also showing the area. Okay, so anyone any question? Okay. Yes, please.
Which ones we added other class in satellite image?
Okay, I don't understand. If possible, you can simply write this question, then it is also better. Okay, simply write the question in here, the chat box. Simply write the question, then it also better.